Hi, this video is going to be how to solve a force problem. So a really basic level problem. I'm going to walk you through the steps of how to solve a problem using forces. And I'm going to be using the problem solving process that's on your equation sheet. So you might want to have your equation sheet handy when you're watching this video, because I'm going to be following that along. So we're going to have a problem with forces. A rightward force of 25 newtons is applied to a 4 kilogram box to move it across a rough surface with a rightward acceleration of 2.5 meters per second squared. Determine the force of friction on the object. Okay, so what's our process? When you look at this and say, I don't know how to start, you look at your problem solving strategy. Draw a picture. Okay, well, that's been the same for every single problem we've done, so that one you probably can start. We had a rightward force applied to a box to move it across a surface. So there's my very exciting box, and we're pushing it, and it has an acceleration to the right, and it's a rough surface, so there's friction. There's my beautiful picture. Figure out your knowns and your unknowns. So I'm going to go back to the problem and say, what do I know? And here we don't have to use the chart of variables like we do in kinematics. Some problems we will, because some force problems require us to use kinematics. This one, we don't have to worry about it. So I'm just going to read through and say, what do I know? So a rightward force of 25 newtons. So we have a rightward pushing force of 25 newtons. 25 newtons to the right. Is applied to a 4 kilogram box. Okay, so kilograms, that's a mass, so 4 kilograms. To move it across a rough surface with a rightward acceleration, here's my acceleration of 2.5 meters per second squared, and again, it's a vector, so I'm going to put the direction in there. Determine the force of friction on the object. There's our unknown. What is the force of friction? Okay, so picture, knowns, unknown. Choose the object of interest. Well, in this case, it's going to be the box. So my object of interest is the box. Draw a force diagram for the object. Okay, and here again, the force diagram is not on your picture. It's totally separate from the picture. You're going to have other stuff in here that's going to be messing up you if you try to put forces on this. So we want a nice, clean, separate diagram for your forces. So there's my box. And we got to think about what forces are acting on the box. Well, I can always put gravity on. So the weight, the force of gravity acting straight downward. And there's a pushing force to the right. So there's my push. What else is acting? Well, if you're done here, this thing is accelerating downwards and to the right. Well, it is accelerating to the right, but yeah, we have other forces. So what's holding it up? What's keeping it from falling down at 9.8 meters per second squared? Well, it's on a surface. So that surface is producing a support force, and this is our normal force, perpendicular to the surface. So our normal force is going to go straight up in this case. And then are we done? Well, it was a rough surface, and we're looking for the force of friction, so I'd better have a force of friction there. We're moving this direction, friction opposes the motion, and it's always parallel to the surface, so friction's going that way. Okay, so there are the forces. I can't think of anything else. It's not interacting with anything else, so force diagram's done. Number 5, choose a coordinate system that aligns with the direction of the acceleration. I'm accelerating to the right, so I'm going to choose our standard coordinate system. There's my plus y, there's my plus x. Easy enough. 6, balanced or unbalanced forces. So this is where we look at the motion of the object and use that to determine if the forces in our two directions are either balanced or unbalanced. Balanced forces means no acceleration. Unbalanced forces produce acceleration. So up, down, in the y direction, I don't see any acceleration. It's not even moving up, down. So up, down, there's no acceleration. We have to have balanced forces. In the x direction, we're told there's an acceleration. So we know that one has to be unbalanced. All right, so horizontally, the forces are unbalanced, which means these two are not equal. Vertically, the forces are balanced, so these two are equal. Okay, 7, force table of X and Y components. And here we go. I'm gonna use this space. Okay, so X and Y components of all of my forces. So what I'm gonna do here is I'm gonna take all 4 forces and figure out if they're in the horizontal direction, the vertical direction, or sometimes we'll have things that are in both. So I'm going to take all 4 forces. So what 4 forces? We had friction, we had the pushing force, our applied force, we have our weight, and then we have our normal force. And for each of these, I'm going to figure out what direction it is. So our friction force is going to the left. That is in the negative X direction. So there's nothing in the Y direction for that, and it is all in the negative X direction. So the friction force is a negative friction horizontally. Pushing force. So the pushing force is horizontal, so there's nothing for it in the Y direction. And this one's in the positive X direction, so that one's going to give me a positive pushing force in the horizontal direction. And then we've got our weight going down, so there's nothing horizontally for the weight, and it's going in the negative Y direction. I shouldn't, this is confusing, isn't it? Nothing. Let's fix that. That's not negative, it just means nothing. You could call it 0, that's probably better. So the weight is all in the Y direction and it's negative. And then we have our normal force, which is again all vertical, and this is going in the positive Y direction. So when we talk about a chart of force components, the XY chart, this is where we're going to look at each force and figure out what direction it is and if it's positive or negative. So when, you might say, would we have something that's in both directions? Well, let's say I was pushing upwards on the box. If I was pushing upwards on the box, it would have a horizontal component and a vertical component. And so that pushing force might have pieces in both of these directions. So that's number 7. Number 8, use Newton's second law in each direction. And here we're going to go back to what we said here. In the X direction, it's unbalanced. That means that when we take all the forces in the X direction, they're going to produce an acceleration in the X direction. And then when we do the same thing in the Y direction, when we add up all the forces in the Y direction, those are going to be balanced. There's no acceleration. So if acceleration is 0, that whole side becomes 0. All right, so unbalanced, balanced. In the X direction, let's add up all the forces in the X direction. So here we have a negative friction and a positive pushing force equals mass times acceleration in the X direction. So that didn't look too bad. In the Y direction, add up all the forces in the Y direction. We have a negative weight, a positive normal force equal to 0, because they all have to add up to 0. All right, what's next? Use a friction equation if necessary. We're not going to use that in this case because we're just solving for the friction force. Use kinematics if necessary. Nope, we don't have to do kinematics. We already know our accelerations. 11, plan how to get your answer and then solve for it. Well, what are we looking for? So now I go back and say, what am I looking for? I'm trying to find the friction force. So this is my question mark. Do I know what the pushing force is? Yes. Do I know what my mass is? Yes. Do I know my acceleration? Yes. Okay, that was easy. I could just use this equation to solve for the friction force. Now this, I'm not going to use for this problem. I don't have to use this equation in this problem because I can solve it with the X direction. It doesn't mean that this is wrong or that it's not useful. It just means that I don't have to worry about this direction for this problem. Most problems you will. So let's figure out what the friction force is going to be. So I'm going to erase. I need a little more room. So I'm going to use that x direction equation, so I need to get friction force alone on one side. So I'm going to bring the friction force over to the other side and then subtract off MA and bring it over to the other side. So I'm going to have a pushing force, that stays, and then I'm going to subtract the MAX over to this side, and then I'm going to add a friction to both sides. My friction becomes positive. So at this point I can figure out what my answer is. 25 newtons minus mass, which is 4 kilograms, times my acceleration, 2.5 meters per second squared. And that's going to be 25 minus, you can do this one, 4 times 2.5. You can do that in your head. That's 10. So the friction force is going to be 25 minus 10, 15 newtons. So there we go. Now, is that a reasonable number? You have no idea what a reasonable friction force is. You don't even know what a newton is often. So here's where we just have to say, okay, well, if the pushing force was 25, I should probably be in the 25 range. If I got something that was 1 newton, I might worry. Again, if it was 10,000 newtons, I would say I probably did something wrong. I'm in the same range here. And that says, okay, I'm probably right. Pretty comfortable with my math. And did I answer the question? Yeah, we wanted to know what is the force of friction on the object. There, the force of friction is 15 newtons. So did we do everything? Solve for your unknown, check your answer. We've got it. So there's an example of a moderately simple force problem. And yes, I did use the entire board for what I'm calling a simple force problem, but I'm just going through the process very clearly. And with force problems, many people say, I just don't know how to do them. This is where the process, following each step, will tell you where your process, what your problem-solving process should be and how to get to the answer. So use your equation sheet to make sure that you go through all the steps, because that's how you're going to get the right answer most of the time, especially if this is your first time with forces and physics. All right, I think that one's done. Good job.